Welcome to Science Aura. I am Dr. Sachi Vale. Today, we dissect the monumental logistics of SpaceX's ambition, transforming the barren, rusted plains of Mars into the next cradle of human civilization. This is not just a dream of exploration. It is a calculated, multi-stage engineering strategy for survival. The journey begins not with pioneers, but with cargo. SpaceX's strategy relies on a fleet of autonomous transport vessels. These ships act as the precursors, delivering essential infrastructure, life support modules, and robotic construction units to the Martian surface before any human foot touches the regolith. Selection of the landing site is critical. SpaceX targets the polar regions. Why? Because these areas hold the key to life, subsurface water ice. By settling near these frozen reservoirs, the colony secures the most vital resource for drinking, breathable oxygen, and rocket fuel production. Once the cargo arrives, automated systems initiate base construction. These structures are designed to shield settlers from intense radiation in the thin CO2-heavy atmosphere. Using local materials, the base will gradually evolve from temporary pods to hardened, pressurized habitats. Living on Mars means confronting a hostile environment. The atmospheric pressure is less than 1% of Earth's. Every dwelling must be hermetically sealed, maintaining a delicate pressure balance. This is the primary engineering hurdle our systems must overcome to keep the colony functioning. Energy is the heartbeat of the mission. Without the sun's full intensity, solar arrays must be massive, supplemented by compact nuclear fission reactors. This hybrid power approach ensures that even during global dust storms, the base remains powered, heated, and fully operational. To sustain long-term life, we must look to the greenhouse. Cultivating crops in hydroponic facilities is essential for a closed-loop food system. By recycling every drop of water and nutrient, the colony moves from total dependence on Earth to becoming a self-reliant Martian ecosystem. The path to Mars is fraught with immense risk and astronomical cost. Yet, each milestone from landing to cultivation represents a triumph of human ingenuity. We are not just visiting, we are building a future among the stars. I'm Dr. Sachi Vale, and this is Science Aura. Consider the immense logistics of supply chains across millions of kilometers. SpaceX must synchronize launches with the planetary alignment, ensuring a steady flow of resources despite the vast, silent void of space separating our two worlds. The robotic precursors include intelligent rovers equipped with drills. Their sole mission is to sample the soil and verify the purity of the water ice, providing real-time data to SpaceX engineers back on Earth to optimize the landing zone. Beyond survival, we must consider the human psychological factor. The isolation of Mars requires modular interiors that mimic Earth's natural light cycles, maintaining the circadian rhythms of the crew working in the deep red desert. Transporting the necessary equipment requires a fleet of heavy-lift rockets. These vehicles are designed for reusability, a core SpaceX philosophy that drastically reduces the price tag per kilogram delivered to the Martian surface. The Martian soil, or regolith, contains perchlorates. Our specialized treatment facilities must scrub these chemicals before the soil can be used in the greenhouses, ensuring the safety of the food supply for the colony. Communication latency is a constant reality. Signals take up to 20 minutes to travel one way. The colony must operate with high autonomy, relying on advanced AI systems to manage daily operations without immediate human intervention from home. Transportation of personnel involves specialized transit ships equipped with radiation shielding. These vessels are the lifelines of the mission, connecting the frontier to Earth and providing the necessary support for the expanding Martian population. Finally, the goal of terraforming remains a distant, long-term vision. By proving we can live within a closed ecosystem on the surface, we lay the groundwork for humanity's expansion into the solar system, one step at a time. The logistical choreography required for this mission is unprecedented. Thousands of engineers, millions of lines of code, and an unyielding commitment to the mission plan are what define the SpaceX approach to interplanetary life. The landing sequence itself is a marvel of precision. Retro propulsion systems must fire at exact intervals to slow the heavy cargo ships down from orbital speeds to a soft touchdown on the uneven Martian surface. Water extraction is the cornerstone of our survival strategy. By melting polar ice, we liberate hydrogen and oxygen, which serve as the foundation for both human consumption and the fuel required to return ships to Earth. The structural integrity of the habitats is tested against Martian wind speeds. Though the atmosphere is thin, the dust storms can last for weeks, requiring robust exterior plating and self-cleaning solar panels to maintain power. Life support systems are the most critical hardware. Carbon dioxide scrubbers and oxygen generators operate continuously, ensuring the air inside the base is as clean and breathable as the air here on Earth. The indoor greenhouses utilize LED lighting tailored to specific plant growth spectrums. This efficiency ensures maximum yield from a small space, providing the settlers with the nutrition needed for long-term health. SpaceX's commitment to reusability extends to the Martian surface. Landing pads are constructed from sintered soil, creating a permanent base for future arrivals and ensuring that every ship can be serviced and refueled for its next voyage. The challenge of building a colony is a multi-generational task. We are currently in the initial phase of proving the technology, but the ultimate goal is a city of millions thriving in the red frontier. Consider the logistics of shipping heavy equipment. Each payload is modular, designed to fit within the fairing of the launch vehicle, ensuring maximum efficiency and cost effectiveness for every single mission to the red planet. The radiation environment on Mars requires shielding. By building habitats underground or covering them in meters of regolith, we create a safe environment for the colonists, protected from the harsh cosmic rays. Energy storage is handled by advanced battery arrays that charge during the day and discharge through the cold Martian nights. This cycle ensures that the temperature inside the base never drops below critical levels. The robotic precursors also map the topography, identifying safe routes for rovers to travel between the base and the water extraction sites, minimizing travel time and ensuring the efficiency of the supply chain. SpaceX is not just building a ship, they are building an entire infrastructure. From launch to landing, from mining to farming, every aspect is integrated into a single, cohesive plan for extraterrestrial colonization. The challenge of the atmosphere is also an opportunity. CO2 can be captured and converted into fuel, a process known as the Sabatier reaction. This allows us to manufacture propellant for return journeys right on Mars. The logistical load is immense, but the payoff is the survival of the human species. By spreading our presence beyond Earth, we safeguard our future against the potential risks that face our home planet. SpaceX's engineering team is constantly refining the design. Every mission teaches us something new, allowing for iterative improvements that make each subsequent journey safer, faster, and more efficient than the last. The landing gear of the transport ships is designed to handle the rocky terrain of Mars. By using adaptive suspension, the ship remains stable even on uneven ground, ensuring the safety of the cargo upon arrival. The water extraction process involves heating the ice to turn it into vapor, which is then captured and condensed. This liquid water is the vital resource that will sustain the entire colony day after day. The greenhouses also act as psychological sanctuaries. The presence of green life in a harsh alien landscape is vital for the morale of the crew, reminding them of the home they left behind on Earth. Energy efficiency is key to survival. By using the heat generated by nuclear reactors to warm the living quarters, the colony reduces its electrical demand, allowing more energy for vital tasks like water extraction. The communication network relies on a constellation of satellites in Martian orbit. These ensure that the colony is always in contact with Earth, providing a constant stream of telemetry and scientific data. Each mission brings more supplies, expanding the capacity of the base. This incremental growth is the strategy for building a sustainable, long-term presence on the surface of the planet. SpaceX's vision is a testament to the power of human ambition. By tackling the challenges of Mars, we push the boundaries of what is possible, creating a legacy that will inspire future generations. The logistics of the return journey are just as important as the arrival. By manufacturing fuel on Mars, we ensure that every visitor has the means to return home, creating a safe and sustainable travel system. The Martian atmosphere is thin, but it still provides enough friction for aerobraking. This technique allows ships to slow down using the planet's own atmosphere, saving significant amounts of fuel during landing. Water extraction is a complex process, but it's essential for a permanent base. By mastering this technology, we unlock the potential for large-scale operations and eventually a self-sufficient colony. The indoor greenhouses are a marvel of modern agriculture. By controlling the environment, we can grow food all year round, regardless of the harsh conditions outside on the Martian surface. The energy needs of the base will grow as the colony expands. By integrating multiple power sources, we ensure that the base always has the energy required to sustain life and support research. The robotic rovers are the eyes and ears of the colony. They explore the surrounding area, ensuring that the base is built in the best possible location, and identifying new resources for future use. The logistics of the mission are a monumental task, but the goal is worth it. By establishing a presence on Mars, we open up a new chapter in human history, one that is defined by exploration and innovation. The atmosphere on Mars is a constant challenge, but it also provides resources. By capturing and utilizing the atmosphere, we can support life and sustain our operations day after day, year after year. The water extraction process is a critical part of the logistics. Without this, the colony would be entirely dependent on supplies from Earth, a situation that is simply not sustainable in the long term. The indoor greenhouses are the heart of the colony. They provide the food and oxygen needed for survival, and they also serve as a source of morale, reminding the settlers of the life they left behind. The energy needs of the base are met by a combination of solar and nuclear power. This diversity ensures that the colony has a reliable and continuous source of energy, regardless of the conditions. The robotic rovers are an essential part of the exploration process. They allow us to study the Martian surface in detail, identifying the best resources and helping us to plan for future expansion. The logistics of the mission are a testament to the power of human ingenuity. By carefully planning and executing every step, we can overcome the challenges of Mars and build a successful colony. The atmosphere on Mars is a challenge, but it is one that we are well equipped to handle. With the right technology and the right plan, we can make this planet a home for humanity. Water extraction is a key part of our survival strategy. By mastering this, we take a major step towards making the colony independent and sustainable, ensuring its long-term viability. The greenhouses are not just for food. They are also a place of solace, a space that connects the settlers to the beauty of life, and they serve as a symbol of our commitment to the mission. The energy needs of the base will only increase as we expand. We are already looking towards new and more efficient energy sources to support the growth of our Martian home. The robotic rovers are a vital part of our exploration team. They provide us with valuable data, helping us to understand the planet and ensuring that we make the best decisions for the colony. The logistics of the mission are complex, but they are also incredibly rewarding. By taking on this challenge, we are pushing the limits of what is possible and expanding our horizons as a species. The atmosphere on Mars is a unique environment, and it requires specialized technology to navigate. We are developing the solutions needed to survive and thrive in this challenging new world. Water extraction is a testament to our ingenuity. By turning ice into water, we demonstrate our ability to adapt and thrive in any environment, no matter how harsh or unforgiving it may be. The greenhouses are a vital part of our life support system. They recycle our waste and provide the oxygen and food we need to survive, making them an essential part of the colony. Energy is the key to everything. By mastering the production and storage of energy, we can support every aspect of life on Mars, from the smallest greenhouse to the largest habitat. The robotic rovers are a symbol of our curiosity. They allow us to explore the unknown and to learn more about the world around us, helping us to grow and evolve as a species. The logistics of the mission are designed to be sustainable. By recycling and reusing everything we can, we reduce our reliance on Earth and ensure the long-term viability of the colony. The atmosphere on Mars is a reminder of our potential. By learning to work with it, we can create a new home for humanity, one that is truly independent and sustainable. Water extraction is a key part of our survival strategy. By mastering this, we take a major step towards making the colony independent and sustainable, ensuring its long-term viability. The greenhouses are a vital part of our life support system. They provide the food and oxygen needed for survival, and they also serve as a source of morale, reminding the settlers of the life they left behind. The energy needs of the base will only increase as we expand. We are already looking towards new and more efficient energy sources to support the growth of our Martian home. The robotic rovers are a vital part of our exploration team. They provide us with valuable data, helping us to understand the planet and ensuring that we make the best decisions for the colony. The logistics of the mission are complex, but they are also incredibly rewarding. By taking on this challenge, we are pushing the limits of what is possible and expanding our horizons as a species. The atmosphere on Mars is a unique environment, and it requires specialized technology to navigate. We are developing the solutions needed to survive and thrive in this challenging new world. Water extraction is a testament to our ingenuity. By turning ice into water, we demonstrate our ability to adapt and thrive in any environment, no matter how harsh or unforgiving it may be. The greenhouses are a vital part of our life support system. They recycle our waste and provide the oxygen and food we need to survive, making them an essential part of the colony. Energy is the key to everything. By mastering the production and storage of energy, we can support every aspect of life on Mars, from the smallest greenhouse to the largest habitat. The robotic rovers are a symbol of our curiosity. They allow us to explore the unknown and to learn more about the world around us, helping us to grow and evolve as a species. The logistics of the mission are designed to be sustainable. By recycling and reusing everything we can, we reduce our reliance on Earth and ensure the long-term viability of the colony. The atmosphere on Mars is a reminder of our potential. By learning to work with it, we can create a new home for humanity, one that is truly independent and sustainable. We are on the verge of a new era. The steps we take today will define the future of humanity, and the work we do on Mars will echo throughout history for generations to come. Thank you for joining me on this journey. The challenges are great, but the vision is clear. We are destined for the stars, and Mars is just the beginning. I'm Dr. Sachi Vale, and this is Science Aura. Keep questioning, keep exploring, and stay curious. Until next time on Science Aura, look up and imagine the possibilities that await us on the red frontier. The future is waiting.